My name is Olivia Fengying Zhao. Today I will be presenting design emotional expressions for reading companion robot. People's perceptions of the robot depend on robot's social capabilities. In other words, how well the robot communicates its speech, emotional expressions, gestures, and etc. Indeed, recent studies in human-robot literature have shown that human teammates' task performance and self-reported mood can be affected by the robot's mood. Children specifically build stronger relationships with robots with affective expressions. Children use more affective language and expressions during the interaction. They also trust the robot more. Further, people also are found to be more engaged with the robots with expressive behaviors. There were several studies that attempt to equip robots with emotional expressions in different channels. For example, Chenda et al. Manipulated the colors of the robots and asked participants to judge the robot's perceived emotion. Beck and colleagues designed 6 dance movements to represent 6 emotions in robots. McCoy and colleagues engineered head and arm movements on robots to show emotional expressions. However, these designs often only involve 1 or 2 types of behaviors. They do not usually include a full range of emotions and are limited in practical use. So in this current work, we drew literature from social functions of emotion, approach avoidance behaviors of emotion, facial coloration, and gestures to inform the design of robots' emotional expressions. We used emotion labels from Plutchik's Wheel of Emotion. Plutchik's Wheel of Emotion defines 8 categories of emotion. Each category includes 3 levels of intensities, thus containing 24 emotion labels. In this work, we introduced 24 distinct emotional expressions on a reading companion robot, Misty 2. Each expression contains a combination of distinct dynamic upper facial expressions, body and arm movements, and a color change. We then conducted 2 validation studies on mTurk. In study 1, 50 participants viewed the videos for each expression. In study 2, additional 25 participants viewed the videos with a description of the social context. After each video, they then had to choose on the Plutchik's Wheel of Emotion what they think the robot was expressing. In study 1, participants watched a video of the robots expressing emotional expressions for each of the emotion labels. In study 2, we added social context. Participants would first read about a scenario, and after that, the robots would make a response along with the expressions that we designed for each of the scenario. Here is an example.
This reminds me of the Thanksgiving meals I have with my family. Everyone stretches around the table to reach their favorite food.
Results are presented in F-score and heat map. F-score represents how accurate the participant recognized each emotion. So the higher the score is, it represents higher accuracy. We consider accuracy above 0.33 as above chance. We also show the participant's choice is in a heat map to show the patterns of responses. In our results, we see that surprise and trust got higher accuracy after adding social context. But if we look at the results in the heat map, we can see that even without the social context, in study 1, participants all tend to choose in the same category but just regard the emotion expressions as different intensity. Another interesting emotion we found is that anger. It seems that the accuracy got reduced with the social context added. However, if we look at heat maps again, we see that participants still choose the responses in the same category but just with different intensity. To summarize, we designed and validated 24 distinct robots' emotional expressions that incorporates facial expressions, gestures, colors, and body movements. This design could generalize to a wide range of social robots. This current work provides a milestone to design an emotional expressive reading companion robot and to study how children could benefit from this robot. This full set of design is available on Open Science Framework. Lastly, I want to thank Nathan White, Bengi Suchotai, Paula Nidensaw, Joe Michaelis, Byoge Mulu, as well as our amazing Misty 2 robot for making this work happen. And thank you so much for listening.